which will be given by Dr. Kirsi Lorentz. But before I introduce Dr. Kirsi Lorentz, I would like to thank personally Kirsi for useful discussions since this concept came during our meeting in Jordan last year over the SESMI users meeting that Kirsi and her team will visit Pakistan for INSC meetings and they will present the beads here. But unfortunately, the situation became different and we could not host you personally, but I am glad that the whole process has gone very well, and thank you very much for all your cooperation during these times. And these presentations are all going very well, and thank you very much for all.
Thank you so much. It's our pleasure to be here, and I would really also, if I may, on this occasion, like to thank you very, very warmly, Dr. Javed Akhtar, as well as in your role leading the International Natya Summer College. You, of course, have a critical role at SESAMI, being a member of the SESAMI Scientific Advisory Committee. And we're very pleased to be here as BEATS, and we look forward to many more occasions to collaborate both with you and the International Natya Summer College, and very much looking forward to the 46th edition, hopefully as you outlined in the inaugural session at the Natya area next year. Thank you very much for having us here and giving us the opportunity to engage with Pakistani scientists and future users for both BEATS and for SESAMI. Thank you.
That's pleasure, Kirsi, and thank you very much. And now I would like to introduce Dr. Kirsi Lorentz. She is the Vice Chair of Steering Committee for the €6 million BEATS EU project, constructing the tomographic beamline at SESMI. She leads the user community building effort for this beamline in the SESMI region, including Pakistan. Kirsi is a faculty member at the Cyprus Institute. Prior to this, she was the director of the Wolfson Bioarchaeology Laboratory at Newcastle University, UK. Dr. Lorentz owns research focuses on synchrotron radiation-enabled human bioarchaeology. In addition to her work on these, she leads two large funded projects with international consortia, including synchrotron radiation facilities, the BioMira and FFMAC projects worth greater than 2 million. She sits in the Cyprus delegation to the SESMI Council. Kirsi represents Cyprus as the management committee member at EU H2020 Cost Action Commulis, and as the Cyprus member in the International Atomic Energy Project, RER 1018. She led the IAEA SESMI training course on synchrotron radiation technique for cultural heritage in 2018 at the SESMI. The topic of Kirsi's presentation is synchrotron radiation micro-CT at BEATS tomographic beamline at SESMI synchrotron, science, application, and how you can be a future user. Yes. Over to you.
Thank you very much indeed, Dr. Akhtar. As I mentioned, it's really a great pleasure to be here, part of the International Natya Summer College, and we thank you very much indeed for this opportunity, and your colleagues for this opportunity to have these presentations and this user community building event at these challenging times. And more than ever, this throws into relief the necessity for international collaboration and opportunities for providing future access and growth potential for our new scientists and researchers. So thank you again. And thank you for the audience. We hope that as I go through the presentation, we've now had 3 presentations on beats already. This is the 4th one on the tomography beamline at Sesame. We hope that you as audience note down your questions so we can have a lively discussion after this presentation. As Axel, the coordinator of the BEATS project, mentioned in the beginning, we are here for you to explore with you the scientific applications, particularly in your domains. And we would very much like to hear from you in terms of the research directions that you would like to explore with this beamline. So I have 2 parts in this presentation, looking at the science applications, particularly in terms of cultural heritage, and exploring how you can become a future user of the BEATS tomography beamline at Sesame. So as we've heard from the beamline scientist, Gianluca Iori, as well as our 2 other colleagues, Andrea Lausis, the scientific director of Sesame, and of course, Dr. Axel Caprolat, who is the coordinator of the EU BEATS project, there are multiple domains of application in terms of the science that can be supported by data acquisition on such a tomography beamline. Here we have some of those identified key domains that we are focusing on in terms of our efforts for building the user community and anticipating the science that can be undertaken at the Sesame BEATS tomography beamline. By no means are these categories exclusive. So if you don't find your own area of research covered by these topics, that does not mean that there is not an opportunity. Quite the contrary, we would like to hear from you. So these are working domains. Any type of material sample with a relevant key scientific question is appropriate for the BEATS science applications. And as mentioned, we focus now on archaeology and cultural heritage, health, biology and food, material sciences and engineering, geology and environment, as well as services to industry and private sector. And of course, the latter domain very much overlaps with these other domains. And here is just a summary slide that Gianluca has already shown during today's proceedings, just to drive home the various domains to which synchrotron computed tomography can contribute in the Sesame region and in Pakistan in particular. So I would like to now start looking at the rich cultural heritage that we have in the Sesame region, starting by the Harappa site, of course, as we are in the context of Pakistan. There are many other sites also from the Pakistan, the wider region, the Sesame region, and all of these sites have valuable archaeological material, cultural heritage, key questions that can be explored in terms of the use of synchrotron radiation tomography, micro-CT approaches in particular. And such questions can really benefit from the application of these new opportunities at the Sesame synchrotron. Andrea has already mentioned also the other beamlines, and in combination with these, we can really look into very exciting applications and opportunities for exploring further the cultural heritage and archaeology of Pakistan. here are some of the sites. I'm sure you recognize them from Pakistan, with some of the key finds from those sites. And many of these, of course, are the UNESCO Cultural Heritage sites, World Cultural Heritage sites. Now, I will look into certain case studies today with you in terms of archaeology and cultural heritage applications of the beats capacity that is being built at Sesame. We'll look at archaeological materials, and here's a list of those particular materials that we will look at briefly today, but there are of course many more. So I would like this to be a sort of a catalyst for your thinking in terms of what else could be done. We'll look at also human bioarchaeology, plant remains and animal remains. And there are very interesting overlaps, of course, with what Gianluca already talked about of the other application domains, from food to materials to health and biology. Of course, archaeological sciences are the application of all humans' current knowledge and techniques to all humans' past knowledge and techniques. And really, in the case of beats, this is exactly what we are talking about, a cutting-edge facility that we can use with great impact to look at the past. So the material remains from the past can be explored in this way to answer key questions about the past. We don't want to just engage in characterization. We want to address key questions in this particular domain of research and science, as well as in others. And this is, of course, key for writing successful beam time proposals to access beats and Sesame. So you see again some of the domains here, including works of art, plant remains, stone artifacts, and so on, as well as a table looking at some of the possibilities. Here we can look at issues from repair to constitution of the artifacts, as well as exploring unknown materials. And I'd like to now go for our first case study, which comes from Cyprus, which is a member of Sesame, of course. And here, I don't know if you can see my arrow on C. You can see beads of unknown materials that come from these burials. And of course, it's interesting to find out per se what material these pendants or beads were made of. But there is even a more important context here. Are they faience? This is an early context. And in this early context, we start seeing incipient developments towards metallurgy and metalworking. And of course, metals are really the basis of our civilization as we know it now. If you look around yourselves, metals are really everywhere. So this is a key technological development in the past. And to understand early metalworking and to further our understanding of resource exploitation and trade in Cyprus many thousand years ago, it's critical that we understand what material these artifacts are made of. Are they faience? Are they something else? And of course, when we look at faience itself, that brings us to the Harappa site in Pakistan. Here, we can use this technology and the approaches that beads will also afford, as in this study already conducted, to look at the microstructure of the beads, which revealed new information about the materials and technology used in their production. And when we look at these questions, these really relate to the context of technological know-how, as well as trade, specialization, and all of these key questions to archaeology, looking at social complexity, economic activity, trade, and long-distance interactions especially. So here the finding was that the beads, although they could have been made by different workshops and from different time periods, in this case at Harappa in Pakistan, the tomography, micro-CT data capture enabled the conclusion to be reached that these beads were produced using the same technology, most likely from the same workshop, and that allows complex archaeological interpretations in this case. The third case study concerns pottery and ceramics. And in this case, we can look at composite materials. And here, the authors, the researchers, have looked at imitation pottery, metal imitating pottery in specific. And again, this is in the context of status, display, and key questions in archaeology. And the synchrotron X-ray computed tomography enabled the details of the metal layer and the interfacial region to be revealed, looking at the silver imitating pottery in great detail, allowing understanding of the technology in the archaeological context. A further study on glass revealed that there are opaque materials distributed throughout the glass matrix, which was yellow in appearance, and a combination with other synchrotron X-ray techniques, something that already was stated as interest by one of the Pakistani members of the audience in this meeting, allowed the authors to deduce that these opacities were lead, particularly with the XRF techniques. And together, in combination with the synchrotron X-ray computed tomography, it could be shown that these opacities were distributed throughout the glass matrix. And this is, of course, very important, again, looking at technological know-how and skills in the past. Textiles. Textiles are something that we, of course, use every day, and understanding the development of textile production, the materials used, and their preservation indeed. They're very rare finds in specific contexts, for example, in combination with copper artifacts. We have preservation of textile fibers, or then we have these mineralization processes. And the fibers themselves can provide valuable information. Types of fibers, are we looking at plant components, animal hair, in context with other questions again. And of course, textiles can range from the wealthy garments for the kings, if you like, to more mundane garments, as well as shrouds in burial and so on. So a lot of mileage there in terms of applications for the region. Wood, another material of interest, there are a lot of remains from the arid regions in and around Pakistan. And here we have an opportunity to look at the species of the wood, looking at the histology without undue intervention and invasive and destructive methods in terms of sample preparation. So virtual histology, if you like, with this set of techniques that is available through the synchrotron radiation approaches to tomography. Papyri. This is, of course, something that comes to mind when we think about Egypt. Here, the examples from Elephantine Island. And again, a very nice example of multimodal data capture, correlated multimodal imaging, if you like, in the synchrotron context. And tomography can produce improved page separation, clearer visualization of small and degraded writings that appear in these historical documents, and indeed with the synergies between the different beamlines at Sesame, this type of very exciting work performed can be also undertaken at Sesame with the Beats beamline completed. Now, in terms of human bioarchaeology, a brief foray into looking at aquatic activity. This is a bone near your ear. It's called the temporal, and here is the ear canal. So in the ear canal, when we perform repetitive aquatic activities, bony growths begin developing, and these are known as the so-called surfer's ear, or more scientifically, the external auditory exostosis. Now, in the ear canal, we can have other growths too. Osteomata, these are benign tumors, if you like, and to distinguish the external auditory exostosis that are proxies for aquatic activity from the osteomata that are pathologies which are not related to aquatic activity, and therefore resource procurement and the big questions in the archaeology of the region, including broad spectrum revolution in terms of development of agriculture and so on and so forth. The synchrotron X-ray computed tomography is key. We need to look at the histology of the bony growths in the ear canal, and of course the museum professionals and officials at departments of antiquities would not like us to cut pieces like this, which are over 10,000 years old. They will be much happier to let us take them to synchrotron radiation facilities, which we have already done in this case to ESRF, but we live in anticipation that we can do this work with the Beats beamline. And I'd like you to all consider what work you could conduct at Sesame, starting to ready yourselves already from now. Now, here we have plant remains. Yet another example. For example, we can look at seed coat thinning between 2000 and 1200 before Common Era. In this case, the Indian archaeological horsegram. And here the question is really about domestication and what type of food resources were exploited and at what stage of domestication. And these are, of course, key questions. The Sesame region overlaps with one of the oldest areas of plant domestication. Okay, and final example today from the cultural heritage domain. we can look at a number of different types of remains that are animal origin, whether they are animal bones that are remnants of food practices or tools, artifacts, and so on. So we can differentiate between different types of bone, different materials, in this case, looking at whale bone, a terrestrial animal bone, ivory, and antler. And of course, these types of bone materials, animal remains, would have had different acquisition routes and prestige in the past. And therefore, there is a critical scientific question there that we can address through synchrotron X-ray computed tomography approaches. Ivory will have a different value to simple bone from the ovicaprids, or sheep goat, as zooarchaeologists call them, since they cannot be differentiated further. It's the same for antler and other exotic aspects. Now let's switch gears a little bit. We've looked at, with Gianluca and Andrea and Axel, how and what type of applications there are for the Beats Beamline. Now the question is, of course, how you can become a future user. And we'll go through some of these resources here. Of course, there's a number of web pages, various contact modes for both existing users and Beamline scientists, various organizations that can provide funding, and then of course the critical issues about sample preparation. And here national and regional laboratory platforms can play a role until such time that we have sample preparation facilities at Sesame itself. However, it's important to be able to prepare samples in advance and to capture data in the laboratory context, to be able to select the samples and to understand the critical questions that can only be answered by synchrotron radiation-enabled data capture. As mentioned, these are facilities that are not on demand and continuously available. So as a user, it's critical to be able to select those very important samples only that require this technology. Okay, and we'll look at a little bit about resources for writing good beam time proposals, and then the Pakistani user community building event coming up, where we would like to invite your participation. So Axel is of course with us here, and there's a Beats website, and Axel's details are here as well as in the final slide. I will not elaborate further on that since that's been already. Sesame Synchrotron has its own webpage, and Dr. Lausi has extensively explored Sesame for us. The Sesame user portal is an important resource for you, and I would like to invite you to visit it and to register. And by registering, you will get all the communications from Sesame. That is the only way that Sesame can send you updates on opportunities. So please do register. And on that note, I would also like to mention to you, if you want to specifically find out more about Beats, do pass us your emails. In the last slide, there will be contact details. And we'd be very happy to hear further members of the audience today. Many of you have already contacted us today via the chat function. And I hope you're also now writing your questions into the chat function on today's meeting so we can have a discussion afterwards. Now, Sesame also have a users committee, and this users committee provides a platform for communication between the Sesame user community and the management of Sesame. And we work very closely with the Sesame scientific director, Dr. Andrea Lausi, and others on this front. And I'd like to highlight Dr. Suheila Rehman, who's also today with us in this meeting. And here's Dr. Suheila Rehman's details as well. Feel free to contact her as well as any of the committee members. Various members have different kind of specializations, and you may wish to contact both your Sesame member, user representative for the committee, as well as other members of the committee who may have expertise in your particular domain of interest in terms of research. Then there are the user community building events. Several of those have taken place already. As mentioned in the beginning by Dr. Akhtar, the idea was that we would now be in person in Pakistan and be able to engage with you in extensive discussions through several days. It's very good to be in this online meeting, and we hope that you engage in discussions both during these days as well as contacting us via email. And we look forward to indeed the opportunity next year to see you in person in Pakistan. So user community building wise, Sesame user meetings are also key. These take place now at Sesame. This was the first time last year, the 17th Sesame user meeting took place at the newly inaugurated Sesame Guest House. And this is also an opportunity as well as to connect with the Sesame staff, Beamline scientists, the scientific director, but also to have a visit, a tour of the Sesame itself and see the developing facilities. Gianluca Iori, of course, is together with us today. Here are the details, and it's critical to contact the Beamline scientist when you start planning your research. Contacting existing users is another way to explore, to brainstorm on ideas for your research. And here are some of the ways in which you can get in touch with existing users. And in terms of the Beamline scientist, here are just to highlight of all the different activities that Gianluca is doing when not communicating with users, but this is of course something that Beamline scientists do, especially in the run-up to the deadlines for Beamtime proposals. It's critical that you contact Gianluca in advance of in the few years' time when it's possible to submit Beamtime proposals. However, I would not leave it at that. Now is the time to prepare for the upcoming use of beats, to start looking at your research questions, your samples, engaging in discussions about feasibility and so on, and exploring aspects and initiatives that allow you to get familiar with the work at specific beamlines with specific techniques. And one of these initiatives is the LAMP. And LAMP has this initiative called the FAST grants, faculty student grants. So one member of faculty who's not familiar with synchrotron radiation or has less than 1 year experience teams up with one of their advanced students and is provided with an opportunity to go to a synchrotron radiation facility. Another question that already came up is sample preparation. And here I would like to highlight that laboratory analysis prior to use of tomography at synchrotron radiation facilities are key to identifying the questions and the samples which require, in this case, synchrotron X-ray computed tomography. Key to looking at the samples and selecting the samples where the data capture cannot be completed in the lab. The remaining questions, the key questions that really warrant the access to a synchrotron. And these are key for writing the beam time proposals. So this is now time to explore this type of activity. And here as an example, the Biomera platform that enables this type of work to take place both in Cyprus as well as regionally. So please, those of you who wish, you're very welcome to get in contact with us. And there are several other initiatives that we can tell you about. How to write a good beam time proposal. Here are some of the categories that you need to address. The key here I'd like to highlight is the motivation for the present proposal. What is the scientific question? What key issue does it address in your domain? It's not enough just to say, well, this type of material has not been characterized before. What is the impact? And also you need to think about why Sesame, why synchrotron? And you need to tell the international peer review panel why this work cannot be done elsewhere. Okay, and here's some resources. Key aspects must be scientifically compelling and competitive. They need to be self-contained. There are, as Andrea mentioned, many proposals for the beam time proposal evaluation panels to go through. So you need to grab the attention as well as be scientifically compelling, and you need to consult the Beamline scientist in advance. It's no good if it's scientifically compelling and self-contained, but is not feasible to be done at a particular Beamline. Now, to flag up what's coming up, we will have the BEATS interactive webinar for Pakistan, 7th to 8th of October this autumn. And in addition to the expert talks, I'd like you to note this one. We would like to invite short talks and or online posters from you, looking at the potential use of BEATS. And here's some of the references. And with this, I would very much like to thank you again for your attention, draw your attention to these contact details for further information. And first and foremost, I would again very much like to thank all the people who have been involved in organizing the International Natyagali Summer College, and especially I would like to thank Dr. Javed Akhtar, who so kindly invited us as the BEATS project and panelists to have this opportunity to engage with you as the future users of BEATS at Sesame. Thank you very much indeed, Dr. Akhtar, and thank you for your attention.
Thank you very much, Kirsi, for a very nice talk. And I think now